Deja vu. That's what you're going to have with this lab. Because after I explain the boiling point lab, you're going to think, well, haven't I done this already? Didn't we do this the last time we were in lab? And the answer is, yeah, you did. The only difference is that this time we're looking at boiling points of liquids and not melting points of solids. So what do I mean when I say deja vu? Well, for this lab, you're going to use your good old newly formed friend called the Thiele tube. So you're going to take the Thiele tube just like before. And this time, instead of a solid sample that we're going to give you in the lab, we're going to give you a liquid sample because liquids have the boiling points and solids have the melting points, right? Okay, so if we don't have enough Thiele tubes, well, good news for you is that you don't get out of the lab. Good news for you is that we have extra large test tubes that do the exact same thing for the boiling point. So if we run out of Thiele tubes and you come in a little late for lab and you don't get the pick of the litter and you have to get stuck with the runt, well, the runt in this case is the extra large test tube that you're going to be given. But you know what? It does the same exact thing. You'll still get a boiling point. Doesn't really matter what you use. We just prefer you to use the Thiele tube because, like we talked about previously, the Thiele tube will give you this convection movement that you want to in order to circulate this hot oil that's inside of the Thiele tube itself. All right, so let's talk a little bit about the Thiele tube again. It's going to be filled with mineral oil just like before. There's no difference here. And the reason is because the mineral oil has a very high boiling point. Now, we can fill this with water. We might have mentioned this before in the past, but we can fill them with water and do the exact same thing. The problem, though, is that water boils at 100 degrees. So if we have a melting point that's above 100, or if we have a boiling point that's above 100, then the problem here is that we'll never get to that temperature. Water boils at 100. When I get to 100, water is going to be evaporating out of this Thiele tube. I can't make this hotter than 100 under normal circumstances, right? So if we've got a solid or a liquid that has a melting point or boiling point above 100 degrees, we cannot use water in the Thiele tube or test tubes. We have to use something like mineral oil that has a much higher boiling point. So boiling point is going to be using the Thiele tube all over again. Now, what goes inside of the Thiele tube? Well, it's something very similar to the setup that we did the last time we were in the lab. What will happen is that you will gather a larger test tube, and inside of this test tube you will place a thermometer. So there's my thermometer and the thermometer bulb. So I've got my thermometer down here in the bottom, and then other than the thermometer, you're going to also take a capillary tube just like you did last time, and you're going to put it into the test tube. Notice the way that I've drawn this, though. This is a inverted test tube. So you're going to turn, or capillary tube, sorry, this is capillary tube. You're going to turn the capillary tube upside down. So the closed end is going to be pointed up, and the opened end is going to be pointed down. Now, these two things do not have to be attached. The only thing that you want them to do is be in the same vessel, and I'll mention that a little bit later on when we take a look at the actual lab write-up itself. But in this test tube, you're going to put a thermometer, and you're going to be putting an inverted capillary tube inside of there. So here is my thermometer, and then this purple thing was my test tube. I want to be careful when I choose the test tube. I want it bigger, but I don't want it too big where it doesn't fit down into this Thiele tube, because if that's the case, then this thing's not going to work for me, right? I need to use some common sense sometimes, and if we're going to put this in the Thiele tube, I want to make sure my test tube fits in the Thiele tube. If not, I'm going to have to start all over. I've wasted my time. The same thing with the larger test tube. If you use the larger test tube, you want to pick something that will fit down into that test tube. So you want to make sure that this setup works before you fiddle with it and waste your time. Okay, then we're going to be given a liquid. The liquid's going to be poured in the test tube, and I'm going to make sure that I cover the bulb of the thermometer, and I want to make sure that I cover the open end of the capillary tube, because if I do not, this thing is not going to work, and again, I've wasted my time. So with this liquid, whether it's my known or unknown, what will happen is that this setup, this whole entire setup, goes into the Thiele tube. And with the bottom of the Thiele tube, just like with the melting point, I'm going to be heating the bottom of the Thiele tube to allow this oil to heat up very slowly. That's the key. You want to take this a little slow. Don't rush it. Patience is the key. Patience is virtue. Okay. So what will happen is that you'll heat this Thiele tube up, and then with the Thiele tube, there's going to be a certain point where you will begin to see bubbles that will leave from the bottom of the capillary tube. And these bubbles will come to you at a very fast pace. I mean, they will really start shooting out of that capillary tube left and right. You'll see tons of them. So when we see bubbles, that is good news, because bubbles means my boiling point is somewhere nearby. Now, the problem is that people associate the bubbles with the boiling point, and they'll say, this is my boiling point. But bubbles does not equal the boiling point. Okay, I can't stress that enough. Bubbles is not boiling. Bubbles is not boiling. Bubbles is not boiling. Okay, well, what does that mean then? Well, all that means is that your atmospheric pressure now is at a point where this trapped air inside of the capillary tube is now able to escape and leave. So that's letting me know my boiling point has already been passed up. So when I see bubbles, I'm going to write this down to the bottom. Bubbles means that my boiling point has been passed, and I need to take off the heat. And when I take off the heat, I'm going to wait until the bubbles stop. When the bubbles stop, what I will see is my liquid will actually be sucked up into the capillary. So at that point, what will happen is that this liquid that's in here, when I take the heat off, this liquid's going to start to cool down. And when the liquid begins to cool down, then the pressure kind of equalizes all over again. And there's going to be a certain point where my liquid will go whoop up into the capillary. You love my sound effects, don't you? I know you do. I could audition for a movie. Okay, so the liquid goes up into the capillary tube. Once the liquid goes into the capillary tube, this is my boiling point. This is really the temperature that I want to record for my known or my unknown. That's the proper process of taking a boiling point with a Thiele tube in the lab. Now, the problem here is that unlike the melting point, well, we do not have an instrument that measures boiling point for me. They do have one. We have an automated system, just like melting point, that does boiling point for us. So they're out there. However, we don't have one. So this is going to be something that we might work on in the future and try to get an automated system that does boiling point for me. So that way you can compare your hand measurements to the instrumentation methods. But for now, we do not have that technology in our lab. We have the melting point system. We have an automated density meter, but we do not have an automated boiling point system yet. Okay, so now let's take a look at the actual lab. What do they want us to do? Now we know kind of the process of what's going to happen here. What do they actually want me to do? Well, we're going to run 6 samples. Oh my gosh, 6 samples. Yes, you've heard that correct. So does that mean that you're going to be in the lab for the entire 3-hour time period? Well, no, not necessarily. These 3 samples, the first 3, will be a known. And this known will be in propanol. And in propanol is a very close cousin to rubbing alcohol that we call isopropyl alcohol. You're going to run this 3 times. So you're going to put the sample into the tube. You're going to heat it up until you see the bubbles. You're going to take the heat off until you see the bubbles stop. And then you're going to record that temperature. Let it cool down another maybe 5-10 degrees. and then put the heat back on it. So that way you don't have to wait forever for it to cool back down to room temp, and you don't have to wait forever before your next attempt as far as the run goes. So this will speed the process up much quicker. So known, the first time through, you do in propanol, you cool it slightly once you obtain the melting point. Once you obtain, and I spelt that wrong. Once you cool this down slightly, you'll then can heat it up right after that. And when you heat it up directly after that, then everything's going to be okay. You'll get the bubbles again. You'll cool them back down. You'll record a second boiling point, and then you'll do that a third time. In propanol should be boiling around 97 degrees. So this is the key. This is what you kind of want to make sure that you can kind of understand and kind of get a boiling point close to 97 degrees. If you can't get a boiling point close to 97 with the first 3 tries, then you're going to have a problem. And if you go on down to the unknown, which is runs 4, 5, and 6, you're not going to be able to feel comfortable with that number. So that's the problem there. So this is the purpose of the first 3. You want to make sure that you can get a textbook number or something close to it before you do an unknown liquid sample. Okay, so what about my unknown liquid sample? I'm going to be doing that 3 times. So this is the lab or something similar to the lab that you're going to be printing off. You're going to see a picture of the Thiele tube here. The problem is that this is for melting point, right? This is not for boiling point. So I see the capillary turn the right side up, and then I see my thermometer right beside of that. This is just showing you what the Thiele tube is all over again, but that is used for melting point, not boiling point. On the second page, you're going to see another diagram, and it shows you that the thermometer is on the outside of the test tube. Notice that's not what we've drawn here. I told you to put the thermometer in the test tube, not on the outside of the test tube, because you get better data. You'll get a better boiling point if you put it in the test tube and measure the temperature of the liquid and not measure the temperature of the oil. So here's the upside down capillary tube. There's my liquid in the bottom. The thermometer should actually go inside of there. And then I'm going to slowly heat this contraption up in the Thiele tube. And then here are my list of possibilities. So I have acetone, benzaldehyde, butanol, T-butyl alcohol, chloroform, ethyl acetate, heptane, hexanes, methylene chloride, methyl ethyl ketone, methyl isobutyl ketone, N-octane, N-propanol, and toluene. These are in order by way of alphabet, so they're alphabetical ordered. Over here are your boiling points. They are not listed in order of increasing boiling points, so just keep that in mind, right? Don't let that chart fool you. So here's N-propanol. That is my known, and N-propanol has a boiling point of 97 degrees. Your unknown could be N-propanol again, or it could be any of the ones listed in this chart. So not everyone will have the same unknown. They will all be different across the board. So don't go to the person beside of you and say, hey, what'd you get? Because chances are they have something completely different than what you've got. The data sheet is very straightforward. Name an unknown ID number up at the top. If we don't know what your unknown ID number is, we don't know what you've got, so we can't grade your lab. Your first, second, and third boiling point attempt for N-propanol, these should be close to 97. And then you're going to average those together. Hopefully you'll get a number that's really close. If you do, then that's a signal that you can move on to the second part, because you can feel really good about the number and the measurement that you're making. Your first, second, and third boiling point attempt for your unknown will be treated the same way. You will average those up, and then you'll put the average here on the blank. Just like going to Vegas, you don't want to put all your money on the blackjack table at one time, or you don't want to put all your eggs in the same basket if you're a farmer. So we do the same thing in the lab. We don't want to put all of our eggs in the same basket. So the next question says, what are 2 of the possibilities from the chart above? We just don't want you to pick 1. We want you to pick 2. Which 2 could it be? And then down here at the very bottom, finally, it's going to ask, okay, now that you've picked out your 2, which one did you choose, and why did you choose that particular one for your final answer, Regis Philman? So who wants to be a millionaire? Me. I want a millionaire on my lab grade, right? Okay, so that's the lab sheet. There's no post-lab questions. My advice to you is that after you get done with the data sheet, turn it in because there's nothing else to do with the lab. And if there's nothing else to do with the lab, then you don't have to think about me for the remaining of the week. And if you don't have to think about me for a couple of days, it hurts my feelings because I'm a very needy person. But you know, it's okay. You shouldn't think about me all the time. You shouldn't think about chemical technology all the time. You shouldn't think about the lab all of the time. So turn in this lab sheet, get it over with, get it done. That way it can be graded. A quick, nice 100 hopefully can go into your grade book, and then everybody is going to be happy. So this is the setup for the bowling point. This is the pieces and parts that you need to do a bowling point. Very similar to a melting point system. There's hardly any difference at all. And you'll go into the lab, things will happen very smoothly, this process will go very quickly, and you'll be in and out within an hour to an hour and a half, hopefully. So that's the story with bowling point and how to use a Thiele tube to do a bowling point. If you like to make a donation so that we can purchase our bowling point instrument for around $6,000 or $7,000, then please write your check out to me. Have a good day. Have fun.